Today I will start the topic correlation regression of probability and statistics, which you have not learned. It was not there in your probability and statistics at all. As you have not learned that, so I want to start. So in correlation regression, what is that process correlation and what is that regression? Okay, yes. So correlation, we have learnt about random variables, right? Random variable yesterday. So here also we will have the random variables x and y. Correlation, okay, between two or more variables. So if suppose we take x and y as random variables, okay, then if there is any relation between them, okay, then that relation will show some effect, like if x changes, y also changes. If those variables are correlated to each other, then change in one will result change in the other. Father son, something. If there is a strong relationship, then if one gets hurt, then it will get affected to the other one also or not. If your friendship is very strong, right, definitely it will affect, right or not? If he has very strong bonding, right? So here correlation gives strength of that relationship. Correlation gives strength of the relationship. Okay. If the variables are correlated to each other, then the change in one results the change in the other one. Like suppose if I write y is equal to a plus bx, a straight line. If I make some change in x, then that will affect y. That will affect y or not? Yes. So x and y are said to be correlated to each other. Now we have different types of correlations there. As I said just now, this correlation gives strength of the relationship, how strong the relationship is there. Okay, I don't make you write. If you want, you write, because I have very less time. Correlation gives strength of the relationship. Okay, we have different types of correlations here. Different types of correlation. Okay, like positive correlation, negative correlation, linear correlation, perfect correlation, non-linear correlation. Okay, so what is positive correlation and negative correlation? If suppose both the variables move in same direction, means as x is increasing, y is also increasing, then they are said to be positively correlated or directly correlated. If suppose one is moving, that is one is increasing and the other is decreasing, then they are said to be inversely correlated or negatively correlated. Then when we call perfect correlation, perfect, if one changes by 1 centimeter, suppose, then the other should also get affected by only 1 centimeter. Same unit change or same amount of change should be there. If x is changing by some amount, then y should also have the same change, same amount of change. Then they are said to be perfectly correlated. Perfect positive, perfect negative. If suppose the first one x is increasing by 1 centimeter, y is also increasing by 1 centimeter, then they are said to be perfect and positive. If x is increasing by 1 centimeter but y is decreasing by 1 centimeter, then they are said to be perfect and negative. Perfect and negative. Then what is linear? Linear correlation. Linear correlation is if suppose x is changing by 1 centimeter, y is changing by 2 centimeters or 3 centimeters, but it should happen continuously. For every x change by 1 centimeter, there should be 3 centimeters change every time. It should not change. Then such a relation is called, or such a correlation is called linear. Then such a correlation is called as linear correlation. Otherwise non-linear. Okay. So every time suppose there is a change in y, for every one, first time 2, next time 4, next time 6, next time 5, 7 and so on. So suppose in that way it is there, then it is non-linear. I said that correlation gives strength of the relationship, and to measure the strength of that relationship, we have correlation coefficient. It is denoted with small r. It is denoted with small r, correlation coefficient. This is called sample correlation coefficient. But population correlation coefficient will also be there, which is denoted with rho, symbol rho. Okay? But in our study, we are not going to use it, that population or sample correlations here. Okay? Just we will learn about sample correlation coefficient only. Okay? So for getting this correlation coefficient, we have many methods. We have many methods like scattered diagram. Okay? Scattered diagram. What is that scattered diagram? I will tell you. Scattered diagram. Then the second one is Karl-Pearson method. Then the third one is Spearman rank correlation method, and we have many more, concurrent deviation and so on. Okay? But we are going to learn only few, because in your exam they are not going to ask in that way in detail. Okay? By any one method you can do that. Okay? So, and scattered diagram. In scattered diagram what we will do is, we will plot all the data points. X value, for this x value, what is the y value? For this x value, what is the y value? In the xy plane, we will plot all the data points. We will plot all the data points. Like, I will show you now. If they concentrate like this, in the form of some straight line, okay, then we say that as, see that as x is increasing, what is happening to y? Decreasing. So inversely correlated or negatively correlated. Okay? So by plotting those, we will get some diagram where all the points cluster or they concentrate in the form of some curve. Okay? So according to that we can decide what is the correlation, how they are correlated, negatively, positively, perfect, linear and so on. Okay? So this is scattered diagram, one way of doing that. The second way, this is the graphical one. Okay? The second way is, I said, which is very important. Okay? It gives you almost exact answer when compared to other methods. That is Karl-Pearson method, Karl-Pearson method, P-E-A-R-S-O-N, Karl-Pearson method. Okay? And third one what we have is Spearman rank correlation method, which is based on allotting ranks. How you get rank? Okay, after conducting exams, you will be given ranks, right? So in the same way here also, we will allot ranks based on merit. Okay, so that method is called as Spearman's rank correlation method. But many a times I saw that it doesn't have exact answer. It doesn't give exact answer. Okay, it is giving approximate answers. Okay, so better to follow Karl-Pearson. Okay, so in Karl-Pearson method, okay, we will find out the correlation coefficient. Okay, before proceeding to that, first we should know what are the properties of R. Okay, this R value will lie between -1 and +1. -1 less than or equal to R less than or equal to +1. When R is equal to +1, perfect correlation, perfect and positive correlation. Perfect and positive correlation. R is equal to -1, perfect and negative. Perfect and negative. R is equal to 0, no, you should not say actually no correlation, no linear correlation anali. Okay, we should not say no correlation, no linear correlation, because with this R we are trying to find out linear correlation, not non-linear. Okay, then -1 less than R less than 0, correlation is partial and negative. minus 1 less than r less than 0, correlation is partial and negative. Then 0 less than r less than 1, correlation is partial and positive. Partial and positive. Yes, this is the formula for finding correlation which is related with covariance, what you have learned in your probability, covariance. E of xy minus E of x into E of y, you have learned that covariance, okay. So, covariance of x comma y by sigma x sigma y, which we can write it as E of xy minus E of x into E of y by sigma x sigma y. When we solve it further, we are going to get the direct formula which we will be using better, by which we can find out correlation coefficient fastly, okay. So, R is equal to summation xi yi by under root summation xi square summation yi square, where capital Xi is equal to xi minus x bar, capital Yi is equal to yi minus y bar every time. But there is one possibility of doing a mistake here, okay, right, that I will tell you, because what I noticed is when evaluated the question answer scripts, I noticed that many times. I will tell you what is the mistake. See that here, you will be given small x small y, small x small y, you are converting it to capital X capital Y. But in some papers, capital X capital Y will be given, you will think that okay, it is given directly, you will use it, you will get wrong answer. If capital X is given, convert it to small x. If small x is given, convert it to capital X, but you have to use that process. X minus x bar, y minus y bar, you have to use it, whatever may be the notation of the variables. But you have to do that process. Without that process, if you are thinking that capital X capital Y is given, I can use the formula, then it's wrong. It's wrong, okay, you will get wrong answer. So don't do that. You have to do that conversion. You have to find out the mean, you have to take the difference, deviations, and you have to calculate by using this formula, okay. Okay. So we'll do one problem. I saw in one of the papers he asked correlation, regression also, but not with so many points, okay, because time will be less, no. So he has given I think 3-4 points, okay. Okay, right then. The coefficient of correlation, find the coefficient of correlation in the following case. In the following case, draw the table now, don't write, draw the table. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns and 2 rows. 9 columns and 2 rows. Okay, height of the father, height of the son. Because we don't have much time, we can't do more than one. Height of the father, height of the son. First block, height of the father. Then below that, height of the son. Now write first row values 65, 66, 67, 67, 68, 69, 71, 73. 65, 66, 67, 67, 68, 69, 71, 73. Second row 67, 68, 64, 68, 72, 70, 69, 70. Okay? Then write the formula there first, or I'll use this better. Okay? Listen, what you have to do is write it as x, y, height of the father will denote it with x, height of the son will denote it with y, small x, small y. Okay, if he has given capital X, capital Y, write the same, but you have to do the changes. So, x y. Then capital X is equal to x minus x bar. Capital Y is equal to y minus y bar. Then what I need? So what you have to do is, first you should write the formula. What I need? I should write the formula first, then according to that I will proceed. Okay. So here first you should write the formula. R is equal to sigma xi yi by under root of sigma xi square sigma yi square, where capital Xi is equal to xi minus x bar, capital Yi is equal to yi minus y bar. So first I should write the formula, then accordingly I can proceed. Okay. So xi minus x bar, yi minus y bar, xi, yi, yi. Then what I need? See that here, after calculating capital X, capital Y, I need capital XY. I need capital XY, I need capital X square, I need capital Y square. So I will calculate that accordingly. Okay. So xi, yi, then square, then yi square. But before proceeding to all these, what I need? Xi minus x bar, yi minus y bar. So I need x bar. So which I will get from this. Okay, what are the values I have? Or else you tell me. 65, 66, 72, 73. What about yi? 67, 70, 70. Now what is x bar? You know how to find out mean? 68.25 is x bar. Y bar? 68.5. Both are almost same. Means are both same. Then what you have to do is, you have to calculate the deviations. Deviations about mean, their means. Okay. Now listen here. 68, okay, 65 minus this one, 66 minus this one, 67 minus this one, and so on you have to calculate. Okay. So then what are the values you are getting? What are the values you are getting? (65 minus 68.25). So minus 3.25, minus 2.25, minus 1.25, minus 1.25, then 0.25, then 0.75, then 2.75, then 4.75. Yes. Then yi minus y bar, this. So minus 1.5, minus 0.5, okay, then 64 minus 68.5, minus 4.5, minus 0.5, 72 minus 68, so 4.5, 2.5, which one? Yes, here 3.5, and here 69 minus this, so 0.5, and this is 1.5. Okay, so no need of calculating sums here. We don't want all these two. Then after this, what you have to do is xi, yi, this into this, this into this, this into this, you have to put the values here. Then this square, this square, this square you have to put here, and these all the squares you have to put here. Then you have to take their sums. Fast. No need to worry, they will give you simple problems only, because I don't have that small problem, so I took one problem so that I can explain. You should tell me what is summation xi yi. How much? No average, total. Some of you do that summation xi yi, some of you do xi square, yi square. 21 is summation xi yi. Summation xi yi. Did anyone get this one? Summation xi yi? 21 is summation xi yi. What about summation xi square? 68.
Minus 68.25.
Minus 0.25.
Then we are getting 0.
Acha. So, okay. So then we are getting the answer as 0. Yes, yes, this is corrected. Minus 0.25. Make a correction. Minus 0.25. Is that 21? Check once. Which one? Yes, this is also changed. 1.5. We changed this one. We changed this one. Check once. So summation xy is 21. Then what is summation x square? Yes? Summation x square is 44. Summation y square? 1 column you take and finish it. Summation y square is 40. So therefore, R is equal to summation xi yi, which is 21. Summation x square with under root 44 into 40. Yes, what is the answer? You can check whether your answer is wrong. Why? Because it should lie between -1 and +1. If it is exceeding those boundaries, then you have done something wrong. Is it closer to 1? Yes? Is it closer to 1? It should be, because you can see the numbers. You can see the numbers, they are almost same in numerator and denominator. So roughly it should be closer to 1. How much you are getting in the square root value? 0.5. So it means that they are weakly correlated. They are not strongly correlated. There is no strong correlation between them. Okay? So like that you have to calculate correlation. Then we'll come to Spearman. Do you want Spearman rank correlation, or shall we go to regressions? Because you need one process, right? What is that regression? Okay? The process, okay, where we can estimate the value of one unknown variable by the value of known variable. The process where we can find out the value of unknown variable with the help of the value of known variable, like y is equal to a plus bx. If I know the value of x, I can find out the value of y. So such a process is called as regression. Does this regression, what it does is, correlation gives, I said, strength of the relationship, and regression gives nature of the relationship. Correlation gives strength of the relationship, whereas regression gives nature of the relationship. How the nature is, what type of relationship they have, okay, that is given by regression. Okay, now how to find out the regression lines? One way is, yes, if there is any relation between them, when we plot the data, then they will form a straight line or they will form some curve. Okay? If the curve is in the form of a straight line, then that line is called as a regression line. So here we will be learning about simple regression and multiple regression. Simple regression is one where we will have only one independent variable, one dependent variable. Whereas in multiple regression, we will have one variable depending more than one independent variables. Like z is a function of x comma y. Z is depending on x and y. So that gives multiple regression. If y is depending only on x, then it is called as simple regression. Okay, one independent, one dependent, simple regression. One dependent, more than one independent, multiple regression. Okay, so here we have different methods to find out regression lines. Okay, but we'll proceed with only one method because we don't have time. Again, with the scattered diagram we can find out. The second is with least squares method, which is very simple. So better I'll try to tell with that. Okay, I'll give the formulas if you want. Okay, but we cannot do with all the methods now. Okay, least squares method is the simpler method to calculate the regression lines. So regression line of y on x, regression line of x on y. We have to find out two regression lines here. Okay, so how to calculate that by least squares? I'll tell you. I'll tell you the other method also. If you want to try, you can try with that also. Algebraic method will be there. Okay, x minus x bar and y minus y bars. Yes, least squares method. Least squares method. Okay, it is the easiest of all. Regression line of y on x. Regression line of y on x. It is given by y is equal to a plus bx. A regression line of y on x, it is given by y is equal to a plus bx. X is equal to a plus by, or we'll use some other constant c and d, okay, to avoid confusion. Okay. Its normal equations are summation yi is equal to na plus b summation xi. Summation xi yi is equal to a summation xi plus b summation xi square. Listen here. First time just apply summation throughout. We have only a constant, right? So it means that a into 1. So we are multiplying with some summation 1 throughout. No need to by heart. Summation throughout. Then that gives summation yi is equal to summation a plus summation bx. Antena? So summation a, if you have n data points, you will get a n times. So that becomes na. That becomes na. Okay? So that's the reason you are getting na. Next, what do you have the other term? Bx. So leaving the constant we have x. So we have to multiply throughout by summation x. Actually that is not the process. For remembering I am telling you. We have least squares method, from where we will get that. So just technique I am telling you how to remember it. Okay. So you have to multiply throughout by summation x for the next case. So summation xi yi is equal to a summation x plus b summation x square. You have to concentrate on this. Don't see again the first equation what you have written here. Okay. This equation also we got from this. This equation also we are getting from this when we are multiplying throughout by summation x. Okay. Right. Then regression line of x on y is given by x is equal to c plus dy. X is equal to c plus dy. Now you tell me what is the normal equation. Its normal equations are sigma x. What I said, for the first one you have to multiply throughout by sigma or summation, right? So multiply throughout by summation, what you will get? Sigma x is equal to nc plus d into summation yi. Then its role is finished. Now we are left with yi. So multiply throughout by summation yi. So summation xi yi is equal to c summation yi plus d summation yi square. These are the normal equations. These are the normal equations. No need to by heart. Just from that you have to take out. First time with summation throughout, second time with xi if xi is there, yi if yi is there. You will get the required normal equations. Once you write this, then you will get the idea what are the terms we need to find out. Okay, what are the terms we need to find out. Okay, the other way also I am giving here. Algebraic method. Write it fast. Regression line of x on y. Regression line of x on y. X on y. See that, x on y. So you should have x on y. Same for remembering I am telling you. X on y, and here also x on y. So this is regression line of x on y. Then similarly, y minus y bar is equal to r into sigma y by sigma x, x minus x bar. This is a regression line of y on x. Yes. Now see that without correlation also we can do, I will tell you. Now in this, if you see, I need our double process. Okay. So this term summation xi yi by summation yi square. Summation xi yi by summation yi square. But here also xi is xi minus x bar, yi is yi minus y bar, that type. Okay. And here this I can write it as sigma xi yi by sigma xi square. This term right there, I don't have space here, this term, or else I will write here, this term is denoted as bxy. bxy. It is called slope of regression line of x on y. Like y is equal to mx plus c, m is the slope. Same way. R sigma x by sigma y is denoted with bxy. It is considered as slope of the regression line of x on y. Similarly, this term R sigma y by sigma x, this is taken as byx, slope of regression line of y on x. Slope of regression line of y on x. Done? So after that, right there, we have to, from correlation you can find out regression lines. From regression you can find out correlation. How? Write the point now. Write the point. R square is equal to byx into bxy. Byx is something, bxy is something. When you multiply them, what is the answer? R square. When you multiply them, the answer is R square. R square is equal to byx into bxy. R is equal to under root of bxy byx. Below that, right there, when both the slopes are positive, take R as positive, take R as negative. Okay, you have to decide according to the slopes. That case will not arise. When we arrange them, that case will not arise. Okay, we arrange them in that way. Okay, then write the next. From algebraic method, it is clear that regression lines passes through their means. Regression lines passes through their means. If I replace x with x bar, y with y bar, 0 equal to 0. If I replace x with x bar, y with y bar, answer is 0 equal to 0. So therefore we can say that regression lines passes through their means. To find means from regression lines, replace x with x bar, y with y bar and solve them. After solving that, you will get their means, x bar and y bar, because they passes through their means. Okay. Now write the question. Calculate the regression lines for the given data. Okay. Draw the table. 7 columns and 2 rows. 7 columns and 2 rows. In the first one, write there price. Below that, demand, amount or demand. So for the first one, you denote with small x and the second one with small y. Then write the values 10, 12, 13, 12, 16, 15. 10, 12, 13, 12, 16, 15. Then second row 40, 38, 43, 40, 38, 43, 45, 37, 43. 45, 37, 43. 40, 38, 43, 45, 37, 43. Okay. Estimate the likely demand. Estimate the likely demand when the price is rupees 20. When the price is rupees 20. I told you already that the process where we estimate the value of unknown variable with the help of the value of known variable. So what you have to do is, first you have to write the equations, regression line of y on x. Write the normal equations, copy the same fast. Write about y on x. regression lines of y on x. And then below that write the regression line of x on y. Regression line of y on x, regression line of x on y. So once you write that, then you will know what is the requirement, what we have to calculate. Did you all write? What is n? How many values are there? 6. So write there n is equal to 6. Then draw the table like this: x, y, xy, x square, y square. No xi minus x bar, yi minus y bar here. We can do fastly. Algebraic method I wrote, but for the least square I did not write anything. So directly you can calculate. No mean is required here. X, y, xy, x square, y square values I want. Yes, you can see from that. I need only these 5 columns. Then draw the table with that, calculate those values and give the summations fast. What is summation x? What is summation y? What is summation xy? What is summation x square? What is summation y square? Which one summation x? Summation x is 13, 1, 3. 41 is summation y. What is summation xy? Summation x, summation y will get. Summation xy. Take square, summation x square, summation y square. 78. N is equal to 6. Summation y is? How it can be 41? You had no. Yes, no mean. I said only summation x total. I did not tell you x bar, y bars. Don't get confused. Summation x by n is x bar. I did not tell you summation x by n. Summation x I want. That's the reason I told you that check the equation what you want. Do we have any x bar over there? No. Then summation x, summation y. What is summation y? 246. Summation xy 319. 3192. X square 1038. Y square 10136. Then what you have to do? You have to put these values in the above equations and you have to solve them. You know how to solve the equations, right? So just you have to solve them. What we have the first equation? Summation y, right? Summation y is equal to na plus b summation xi, right? Then summation xi yi is equal to a summation xi plus b summation xi square from the normal equations. So I'll dump all those values in this. So 246 is equal to 6a plus 78b. Then summation xi yi 3192 is equal to a summation xi means 78a plus b summation xi square 1038b. Solve these two equations, then you are going to get a value, b value. These are the two unknowns. Then similarly second set I have to calculate. Okay, regression line of x on y. So summation x is equal to, or summation xi is equal to nc plus d summation yi. Then summation xi yi is equal to c summation yi plus d summation yi square. Okay, so this will give, I am writing here, summation xi is 78 is equal to 6c plus d summation yi means 246d. Then this will give summation xi yi 3192 is equal to 246c plus 10136d. 3192 is equal to 246c plus 10136d. You have to solve this, you will get the value of c and d. You will get the value of c and d. So tell me what are the values of a and b, tell me what are the values of c and d. So Any big number is also given, then it should not be a problem to you. You will have calculator. Okay. So tell me what is A and B? What is A and B? Yes? 44.25 minus 0.25 is B. Okay, I am writing here. A is 44. Okay. A is 44.25 and B is minus 0.25. I hope you all know how to solve the equations in calculator. What is C is 17.92, D is minus 0.12. Put these values, then you will get regression line of y on x, regression line of x on y. Y is equal to a plus bx you wrote, and x is equal to c plus dy you wrote, right? So put those values in that, then you are going to get two regression lines, regression line of y on x, regression line of x on y. Then tell me what is the regression line of y on x? Y is equal to 44.25 minus 0.25x. This is regression line of y on x. Regression line of x on y, x is equal to 17.9 to 0.1 2y. Okay, so regression line of x on y, regression line of y on x we got. Now what is the question asked? Estimate the value of? Estimate demand when price is 20. Okay, when x is 20, x is price. Okay, so you have to calculate y when x is 20. So first equation you have to use. First equation, put x is equal to 20 in first equation here, equation A. Then y is equal to 44.25 minus 0.25 into 20. How much? 39.25. One more thing I want to tell you, whatever the answers you got, whether they are right or not, you can check. An answer is right or not, roughly you can check. If the data is not randomly given, if that is in order, you can check. How? See the tabular values what you are given. Tabular values లో ఏదో ఒక వాల్యూ వేసి చెక్ చేసుకోండి, అర్థమైపోతుంది, ఆన్సర్ మ్యాచ్ అవుతుంది. ఓకే, మ్యాచ్ విత్ ద tabular values, roughly it will match. If it is not matching, then whatever the answer you got is wrong. If it is not matching, then your answer is wrong. Roughly it should match, right? So this was regression. From this you can also find correlation, I said. How? Byx, bxy you have to take out. Byx and bxy. Okay, I'll show that also here. Byx and bxy. Okay, so what is byx in this? Y depending on x. So this will become byx. Byx is minus 0.25. Bxy is minus 0.12. Then r is equal to under root of minus 0.25 into minus 0.12. Tell me the answer. Under root of minus 0.25 into minus 0.12. So I am telling you with the regression lines how to find out correlation. From correlations, I wrote what is the formula to get regression. 0.17. But see that both are negative, so R should be, both are negative, so R should be negative. R is equal to minus 0.17. So weakly correlated. Okay. So like that you can find out. Okay, so that was all about correlations and regressions. We will have 10 minutes break, then we can start. Same technique I used there, you can observe. See that here? First I applied summation, then I applied summation xi throughout, then I applied summation yi throughout. No need to by heart. So if multiple regression problem is also given, you can use the same technique of least squares. What are the equations you got? Y is equal to 44.25 minus 0.25x, x is equal to 17.92 minus 0.12y. Okay. Yes, such equations will be given and you will be asked to find out their means. I told you a note. You have to replace x with x bar and y with y bar and you have to solve them, then you are going to get the mean. Replace x with x bar, y with y bar and try to solve it and check what are the means you are getting. X with x bar, y with y bar. You got two equations, no? Replace x with x bar, write there x bar, y bar and solve those two equations. Then you will get the values of x bar and y bar. You can cross check with x bar, y bar from the data what you have. So you can cross check, the value you will get same there. From the two equations you have to replace x with x bar, y with y bar, solve them and you can check with the data what he has given. Suppose two equations are given, you have to replace x with x bar, y with y bar, solve it, then you are going to get the means. Because we have already done here, I am not getting any question in that. So that's the reason, because we have done. So you can replace their x bar, y bars, x with x bar, y with y bar, solve it, you will get x bars and y bars. If you want you can check, because that is also one type of question. Is that matching? From those equations we can get correlation coefficient and also their means. Just you have to solve those two equations by replacing x with x bar, y with y bar. Okay, this is multiple regression line. I am not making you do any problem on this. Write the normal equations. If given, you have to apply this. Same technique of least squares what we have applied for simple regression. Because you did not learn SVD, singular value decomposition. So just I will brush up all the topics of eigenvalues, eigenvectors once, then I will go to SVD. Okay? Do you remember eigenvalues, eigenvectors, how we found? Eigenvalues and eigenvectors when the matrix is given. When the matrix is given, determinant of A minus lambda I is equal to 0. This is called as characteristic equation. And here lambda is called as characteristic root. When we expand this, we are going to get some equation. That equation is called as characteristic equation and the root what we get from that is called as characteristic root, or we call it as eigenvalue. So lambda is your eigenvalue. Okay, but I don't use this one. Why? Because most of the times we'll do some mistakes with this. So instead we will write it like this: lambda square minus lambda into trace plus determinant of A is equal to 0 for 2 by 2 matrix. 3 by 3 minus lambda cube plus lambda square into trace minus lambda into sum of minors of diagonal elements plus determinant of A is equal to 0. This is for 3 by 3 matrix. Minus lambda cube plus lambda square into trace minus lambda into sum of minors of diagonal elements plus determinant of A equal to 0. You can write determinant of A minus lambda is equal to 0 and you can solve it. Okay, I will tell you that way also in the beginning, but because there is a chance of making some mistakes over there, so I will skip that. I will use the direct formula there, which we got on solving the determinant of A minus lambda equal to 0 only. Okay, eigenvalue is nothing but the root of the characteristic equation. Then what is eigenvector? Okay. The non-zero vector capital X such that Ax is equal to lambda x is called eigenvector. It is non-zero vector. Don't write 0, 0, 0. It is a non-zero vector. Okay. If X is eigenvector, then Kx is also eigenvector. Corresponding to same eigenvalue lambda. 1, 1, 1 is the eigenvector, then minus 1, minus 1, minus 1 is also the eigenvector. 2, 2, 2 is also an eigenvector. 3, 3, 3 is also an eigenvector. But we take in most of the cases the least numbers, 1, 1, 1. If you are getting 3, 3, 3, so we'll make it as 1, 1, 1. So you have to remember that X is a non-zero vector, and if X is eigenvector, Kx is also an eigenvector. One more thing you can check, okay, is for any problem you can check whether whatever the values you got are right or not with, write a note, sum of the eigenvalues is equal to trace and product of the eigenvalues is equal to determinant. Sum of the eigenvalues equal to trace and product of the eigenvalues is equal to determinant. Sum of the eigenvalues equal to trace and product of the eigenvalues equal to determinant. Sum of the eigenvalues equal to trace and product of the eigenvalues equal to determinant. Okay, and we have still many more properties. I'll make you write after doing one problem. Okay, take one problem. Find eigenvalues and eigenvectors of 2, 2, 1, 1, 3, 1, 1, 2, 2. 2, 2, 1, 1, 3, 1, 1, 2, 2. Okay. So for this, find out what is trace. Trace, sum of the diagonal elements. Sum of the diagonal elements. So minus lambda cube plus lambda square into trace minus lambda into sum of minors of diagonal elements plus determinant of A is equal to 0. So trace is how much? 7. What is determinant of A? Determinant of A 5. And what are sum of minors? Tell me the matrix. Just I'll repeat that once. 2, 2, 1, 1, 3, 1. Okay, listen here. Sum of minors of diagonal elements. So this is the diagonal. So for this, leaving this row, leaving this column, find out the determinant 2 by 2. So for this 3, 2, 6, 6 minus 2, 4. So 4 you are getting plus. For this, leave this row, leave this column. Then 2 into 2, 4. 4 minus 1 is 3 plus. For this, leave this column, leave this row. Then take 2 by 2 determinant. That is 2 3s are 6. 6 minus 2 is 4. So plus 4. That is 11. Sum of minors is 11. So therefore, characteristic equation is minus lambda cube plus 7 lambda square minus 11 lambda plus determinant of A, that is 5, equal to 0. Or I can write lambda cube minus 7 lambda square plus 11 lambda minus 5 is equal to 0. Then you have to find out roots of this equation, which are called eigenvalues. As what are the roots? Lambda equal to 1, 5, 1. So roots are repeated. Okay, when repeated, from single eigenvalue you will get 2 eigenvectors. Okay, listen here. Put lambda is equal to 1 in A minus lambda I into x is equal to 0 to get the eigenvectors. Right? We'll get From determinant of A minus lambda I equal to 0, we get the characteristic equation. So again I am using the same system whatever is given. A minus lambda I into x is equal to 0. Ax is equal to lambda x I wrote for eigenvector. So bring that lambda x this side. So that becomes Ax minus lambda Ix equal to 0. So A minus lambda I into x is equal to 0. Okay. So if I put here lambda equal to 1 in this, A minus lambda I into x equal to 0. 0, 0, 0. A minus lambda I. So 2 minus lambda 2, 1, 1, 3 minus lambda 1, 1, 2, 2 minus lambda into x, y, z. So put lambda equal to 1 in this. So that gives 1, 2, 1, 1, 2, 1, 1, 2, 1, x, y, z equal to 0, 0, 0. Then after that what you have to do is you have to select two different equations. Do you have two different equations in this? No, we have only one equation. So we have to take one equation and we have to solve it. We get two solutions from that. Because lambda is repeated twice, from one, in most of the cases you will get two solutions, most of the cases where we will get only one solution. There are some cases. Okay, 99% of the cases we will get two eigenvectors. There are some cases where we don't get two eigenvectors. Such cases where the matrix is not diagonalizable, where we don't get two eigenvectors whenever repeated, in such a case the matrix will not be diagonalizable. Okay, we will see what is diagonalizable for this problem only. Okay. So right there, select any two different equations. Select any two different equations, but we don't have, we have only one. Okay, so we will select only one now. So x plus 2y plus z is equal to 0. How many unknowns are there? How many equations are there? How many we are free to choose? Two values we are free to choose, right? So let z is equal to k1, y is equal to k2. Then I will get x plus 2k2 plus k1 is equal to 0. So x is equal to minus k1 minus 2k2. X is equal to minus k1 minus 2k2. Then you will get an eigenvector. X is equal to x value, that is minus k1 minus 2k2. Y value is k2. Z value, that is k1, like this. In place of k1 here nothing is given, so I will make it as 0. Here in place of k2 nothing is given, I will make this as 0. So I can split this into two parts, so I will get two eigenvectors from that. So I can rewrite this as k1 times of minus 1 0 1 plus k2 times of minus 2 1 0. You can put these in the equations and you can see they will satisfy. If not satisfying, then you have done something wrong. Okay, this is for the case when the eigenvalue is repeated. Okay, then we will see for lambda is equal to 5 also. If you put lambda equal to 5 in this, put lambda equal to 5 in A minus lambda I into x is equal to 0. Then we get that as 2 minus 5 is minus 3, 2, 1. Then 1, 3 minus 5 is minus 2, 1. 1, 2, 2 minus 5 is minus 3, x, y, z, 0, 0, 0. Now can we select any two different equations from this? Any two different equations? Yes, we can select, right? So what are the two different equations? They are all different. They are all different. So I will select suppose this and this. Then solving that, x minus 2y plus z is equal to 0, x plus 2y minus 3z is equal to 0. Then x, you have learnt in intermediate, minus y, z. For x leave this, then minus 2 into minus 3 6, 6 minus 2 4. For y leave the y terms. So 1 into minus 3 minus 3, minus 3 minus 1 minus 4. For z leave z terms. So 1 into 2 2, 2 plus 2 is 4. 4 4 4. So you can write the eigenvector as 1 1 1. If something is wrong, what you will do is, sometimes you will forget this minus sign here. If you forget, it will not satisfy here. So I'll put here minus 3 into 1 plus 2 into 1 plus 1 into 1, 0. So you can check in that way. Suppose you missed this minus sign, it will not satisfy. You will have the answer as 1 minus 1, 1, which doesn't satisfy in this. Okay, so you can check. And eigenvalues ko check cheyandi cheppanu kada, sum of the eigenvalues equal to trace and product of the eigenvalues equal to determinant. What are the eigenvalues we got? 1, 1, 5. 1 plus 5. What is the trace? 7. Determinant 1 into 5. Yes. So every time check that. Don't proceed to eigenvectors before checking. So whenever you find out eigenvalue, check with that property. Sum of the eigenvalues equal to trace, product of the eigenvalues equal to determinant. Then proceed to eigenvectors. So here we got 2 eigenvectors. Okay, and this is the third one. So x3 is equal to 1, 1, 1. So I'll write here x1 is minus 1, 0, 1, x2 is minus 2, 1, 0, and x3 is 1, 1, 1. So in this way we will find out eigenvalues and eigenvectors. By using the same example, I'll tell you diagonalization also, Cayley-Hamilton also. Okay. So we got 3 eigenvectors. Do you remember? Yes, if you want, write the note there. So same problem, I'll tell you diagonalization also. Right there. If the eigenvalues are distinct, eigenvectors are linearly independent. Hence, given matrix is diagonalizable. Then write the next point. If the eigenvalues are not distinct, corresponding eigenvectors may or may not be linearly independent. Hence, may or may not be diagonalizable. Now see that here we have the case may or may not be. So you have to find eigenvectors. May or may not be diagonalizable. Okay. Then below that right there, form the modal matrix. By using eigenvectors. P equal to x1, x2, x3. In whatever order you are writing, the same order you should follow even to write D. In the same order you should follow to write D also. What is that? I'll tell you. P is equal to x1, x2, x3 and diagonal matrix D equal to lambda 1, lambda 2, lambda 3. Same order. For lambda 1 I got x1, for lambda 2 I got x2, for lambda 3 I got x3. Same order should be followed in both the cases. It's up to you. If you want to write x3 first, okay, write that. Then write the lambda 3. Like that. Whatever the order you are following, for eigenvectors you should follow the same order to eigenvalues also. Okay. Now, we got eigenvalues. Are they distinct? No. So there is a confusion now. It may or may not be diagonalizable. Okay. So write a note there. A matrix A is said to be diagonalizable. If there exists an invertible matrix P, such that P inverse AP equal to D, that condition should be satisfied. Actually, we never check, because according to the note, if independent, diagonalizable, we never check. We need not check it. Okay, whenever the eigenvalues are distinct, eigenvectors will be linearly independent, hence the matrix is diagonalizable. P inverse AP equal to D, we need not check. But when the eigenvalues are not distinct, we need to check what is P first. What is P? Otherwise not at all required. When their eigenvalues are not distinct, then only we have to check. That also, what we have to check? We have to write P and we have to find out its determinant, not at all required. Okay. So what we have to do here, because the eigenvalues are not distinct, I have to write what is P. I have to check whether it is non-singular or not. Enduku P inverse AP equal to D. If it is singular, P inverse will not exist. If it is singular, P inverse will not exist. So I need to find out what is P. Okay. So here P is equal to minus 2, 1, 0, 1, 1, 1. Write this P. Then find out its determinant. Then after it's enough. With that we can say whether it is diagonalizable or not. What is determinant of P? Determinant of P is minus 2, which is not equal to 0. Hence P inverse exists. P inverse exists. So it will definitely satisfy now. Okay. P inverse exists. Hence matrix A is diagonalizable. Matrix A is diagonalizable. And P inverse AP equal to D. So Cayley-Hamilton theorem. We'll take same problem. So take the same question. Why to waste time? Take the same question, write that. State and verify Cayley-Hamilton theorem and find A inverse. Verify Cayley-Hamilton theorem, find A inverse. Verify Cayley-Hamilton theorem and find A inverse. Take the same question, write the up to characteristic equation fast. Same question, up to characteristic equation, write down. What is the characteristic equation we have? Lambda cube, 7 lambda square, 11 lambda minus 5 is equal to 0. Characteristic equation. You can apply it to any equation, any matrix, because according to the statement, every square matrix satisfies its own characteristic equation, any square matrix. So I took some, you can take any. Okay. So right there, every square matrix satisfies its own characteristic equation by Cayley-Hamilton theorem. Every square matrix satisfies its own characteristic equation by Cayley-Hamilton theorem. So we get A cube minus 7A square plus 11A minus 5I is equal to 0. One mistake you will do here, you will forget to write I. You should avoid that. I should be there. You will replace lambdas with A, but you will forget this I. Why? Here there is no I. But because we wrote that in terms of matrices, this cannot be a constant. It should also be written in the form of matrix. Okay, 5I. Now for verification, what we have to do? We have to find out A square, A cube, and we have to dump all those values. Then it should get satisfied. Okay. So we'll leave there, find A cube, A square, and put and check. Yes, it should satisfy. Now to find A inverse, pre-multiply by A inverse both sides. If you want to find A inverse, then multiply both sides by A inverse. So that gives A inverse of A cube minus 7A square plus 11A minus 5I is equal to 0. So which gives A square minus 7A plus 11I minus 5A inverse equal to 0. So which gives A inverse equal to 1 by 5 times of A square minus 7A plus 11I. So already you will have all those values, dump in that, then you are going to get A inverse. Okay. So dump all those values, then you are going to get A inverse. So diagonalization is done, Cayley-Hamilton theorem, write some properties, it may be asked. Okay, not directly, some questions may be asked based on that. Write it fast. If lambda 1, lambda 2, so on up to lambda n, if lambda 1, lambda 2, so on up to lambda n are the eigenvalues of A, then, okay, in one only we will write that all those. 1 by lambda 1, 1 by lambda 2, 1 by lambda 3, so on, 1 by lambda n are the eigenvalues of A inverse. So what I should write there? It should be a non-singular matrix then. Okay. If lambda 1, lambda 2, so on, up to lambda n are the eigenvalues of A, in bracket write there non-singular. Because 1 by 1 by 1 by, if it is singular, you will get one of the eigenvalues as 0. One of the eigenvalues will be 0. K lambda 1, K lambda 2, so on, are eigenvalues of K. Third, lambda 1 power n, lambda 2 power n, lambda n power n are eigenvalues of A power n. Lambda 1 minus K, lambda 2 minus K, so on, or plus or minus K are the eigenvalues of A plus or minus Ki. Then note, if lambda is eigenvalue of A, then determinant of A by lambda is eigenvalue of adjoint of A. Note, eigenvectors corresponding to distinct eigenvalues are linearly independent. If you have two distinct eigenvalues, then their corresponding eigenvectors will be linearly independent. Zero is the eigenvalue of A if and only if A is singular. If you have the singular matrix, you will get one of the eigenvalues as 0 there. And if 0 is the eigenvalue, then definitely your matrix will be a singular matrix. Sometimes you will be given a matrix which is a triangular matrix or diagonal matrix. So with that you can find out eigenvalues directly. Just take the diagonal elements. After that, write one more note. Eigenvalues of diagonal matrix or triangular matrix are given by its diagonal elements. No need to calculate. Directly we can take out. Eigenvalues of diagonal matrix or triangular matrix are given by its diagonal elements. No need to find out, no need to write the characteristic equation and all. Just take out the diagonal elements. They will become eigenvalues. Then quadratic form, do you remember? Quadratic form, a homogeneous polynomial of second degree. A homogeneous polynomial of second degree. Homogeneous, so throughout it will have the same degree, like x square plus y square plus 2z square plus 3xy plus 2yz plus 3zx. It's a quadratic form. From quadratic form you can get matrix, from matrix you can get quadratic form. You have learned. Okay? So how to write it? It will give you a symmetric matrix. Okay, look at that. What do you have to do? Write the coefficient of the square terms along the diagonal. So 1, 1, 2. Put the coefficient of the square terms along the diagonal. Then next what you have to do is, you have to split product terms into two parts. 3xy, I can write it as 3 by 2 xy, 3 by 2 yx. This is x, y, z, x, y, z. So I can write here 3 by 2, I can write here 3 by 2. Then split another product, that is 2yz. 2yz I can write it as yz, zy. Yz coefficient is 1, zy coefficient is also 1. So yz coefficient is 1, zy coefficient is 1. Then last product is 3zx. So 1. Yz, zy. Then 3zx. 3zx we can split into 2. 3 by 2 zx, 3 by 2 xz. 3 by 2 zx So here 3 by 2, 3 by 2 xz, so here 3 by 2. So like this, when the quadratic form is given, you can convert it to matrix. Then finding eigenvalues, eigenvectors, again it is the same process for this, but you have orthogonalization. In orthogonalization, after finding eigenvalues, eigenvectors, see that this is a symmetric matrix, so we can apply orthogonalization for symmetric matrices. Okay, so we have to find eigenvalues, we have to find eigenvectors, but one thing extra is you will have norms. So L1 norm, L2 norm. Okay, suppose you have like this 1 minus 1 1, 1 minus 1 1, L1 norm, L2 norm. What we are using is L2 norm. If you remember or if you recall what we have done when we find normalized eigenvectors, under root of 1 square plus minus 1 whole square plus 1 square. Did you remember? Here when we find out norm, we wrote it like this, equal to under root of 1 square plus minus 1 whole square plus 1 square. This is your L2 norm. L2 norm. L1 norm is just taking modulus. Okay, like L1 norm I can write it as 1 plus minus 1 plus 1, just taking mod. This is your L1 norm, not squaring it, modulus, taking modulus just all. So 1 plus 1 plus 1, that becomes the L1 norm. L2 norm is, will get here under root of 1 square plus minus 1 whole square plus 1 square. L1 norm, L2 norm. Here we are not using L1 norm, maybe in machine learning and all they are using, but here we are not using that L1 norm, we are using L2 norm only. It is used as regularizer for your machine learning. L1 norms and L2 norms, they are being used in machine learning. Let's take this, or will you do that? Shall I start SVD? You will do orthogonalization, you know the procedure, or when I tell you that SVD, I will tell you the brief of that orthogonalization also at that time, because you did not learn SVD. Till finding eigenvalues, eigenvectors, it will be same in orthogonalization as well as in SVD, same process, but in the beginning we will have change. Yes, in diagonalization, see that what was the final form we got? P inverse AP equal to D. P inverse AP equal to D. If we are able to get that form, then we are saying that it is diagonalizable. Or we wrote there that for any matrix A, if there exists some invertible matrix P such that P inverse AP equal to D, then we are saying that the matrix A is diagonalizable. Okay. So for getting this SVD, singular value decomposition, okay, I think you have learnt even this LU decomposition, upper triangular matrix, lower triangular matrix, splitting the matrix, solving the system of equations by splitting that coefficient matrix into two parts, L, U, lower triangular matrix and upper triangular matrix. Okay, if time permits, I'll tell you. Okay, so here what we are doing is, we'll split that matrix as A is equal to U, D, V star, where U and V are given by normalized eigenvectors. U and V are given by normalized eigenvectors. How you are getting D? It is given by square root of the eigenvalues whatever you get here. D. In diagonalization, you saw that the diagonal matrix is formed by writing eigenvalues along the diagonal. But here, instead of writing the diagonal values, we'll write square root of the eigenvalues. Square root of the eigenvalues we'll write here. Those values are called singular values. Okay, so that's the reason we are calling such a decomposition as singular value decomposition. Okay, where A is equal to U D V star. What is the advantage? Why we need this? When we are learning about diagonalization and orthogonalization, why I need this? Singular value decomposition. And it is considered as very important for you in your placements and machine learning and all. Why? Because this can be applied, listen, this can be applied to not only real matrices, this can also be applied to complex matrices. Not only that, this can be applied to any rectangular matrix, it need not be a square matrix. Till now what we have seen is only for square matrices. Where I took rectangular matrix? No. But I will show you with rectangular matrix here. That is the advantage. Okay, you can apply this decomposition by taking any matrix, or you can apply it to rectangular matrix, complex matrix, or real matrix. Okay, to any type of matrix you can apply this. That's the reason it is considered as important. Okay, D is formed by writing square root of the eigenvalues. Square root of the eigenvalues. Till now, D was written as eigenvalues along the diagonal elements. But here we will consider square root of the eigenvalues, and those values are called singular values. Okay, singular values. Left singular matrix, V is called a right singular matrix. Conjugate transpose of V. If suppose it is a real matrix, then V star will become, see that I wrote that for general case, it may be real, it may be complex. V star is nothing but conjugate transpose of V. If suppose it is a real matrix, then V star will be normal transpose. No conjugate will be there. So I can write there in place of V star as just V transpose. Just V transpose. Because it is a real matrix. Real matrix will not have any conjugates. Conjugate will be the same element. Right? So I wrote that for the general case. It may be for real, it may be for complex. Okay, it can be a rectangular matrix also. Okay, for general I wrote. So according to the case, you have to modify it. So write the note, for real matrices, V star is equal to V transpose. For real matrices, replace V star with V transpose. V star with V transpose. Write the question to tell you that this can be applied for rectangular matrix. I took rectangular matrix only. It can be applied to square, complex, real. Okay, because till now we have done with only square matrices. Okay, so I will tell you with rectangular matrix. Write that. Find the singular value decomposition. Find the singular value decomposition of A equal to 3, 1, 1, minus 1, 3, 1, minus 1, 3, 1. But here, as here, you are given a rectangular matrix, so you cannot apply the concept of eigenvalues, eigenvectors, or getting the characteristic equation directly. So you have to do some changes to that. Okay, that's the reason I wrote there. If you see, if you check your papers, I wrote there that you have to find eigenvalues and eigenvectors of B and C. B is equal to A into A transpose, and C is equal to A transpose into A. Means you can convert that rectangular matrix to square matrix. Okay, so you have to convert in that way. So A transpose is equal to 3, 1, 1, minus 1, 3, 1. Find B equal to A into A transpose. A into A transpose. Find C is equal to A transpose into A. And tell me what you are getting the answer. A into A transpose into A. 5, this one 5, 1, 1, 10. This is 2 by 3, this is 3 by 2, so I'll get 2 by 2. Is that 5, 1, 1, 10? 11, 1, 1, 11. 11, 1, 1, 11. Then tell me what is C? What is C? So it will become a 3 by 3 matrix now. 10, 0, 10, 0, 2, 0, 10, 4, 2, 4, 2. Check once. Correct? 10, 0, 2, 0, 10, 4, 2, 4, 2. So now what you have to do is consider B, find the eigenvalues. Consider C, find the eigenvalues. Do that now. First, take B, will complete the process finding eigenvalues and eigenvectors. Same process after that. Consider the matrix B, find eigenvalues and eigenvectors. As for B, characteristic equation is, as it's a 2 by 2 matrix, so lambda square minus lambda into trace plus determinant of A is equal to 0. Lambda square trace is 22 plus determinant 121, so that becomes 120. Lambda square minus 22 lambda plus 120 equal to 0. Then what are the roots? 10, 12. Lambda equal to 10, 12. Put lambda equal to 10 in A minus lambda I into x is equal to 0, or B, sorry, not A. B minus lambda into x equal to 0. So that gives 11 minus 10, 1, 1, 11 minus 10 into x, y equal to 0, 0. Because you know already the process. I am writing directly. In A minus B minus lambda into x equal to 0, this matrix, this minus lambda, this minus lambda. So that gives 1, 1, 1, 1. So I will have only single equation, x plus y equal to 0, x plus y equal to 0. So x plus y is equal to 0. Then x is equal to minus y. Let y is equal to k. Then x is equal to minus k. So therefore I will get the eigenvector as minus 1, 1 times of k, or okay, we will remove that. Minus 1, 1, or write it as 1 minus 1. Okay. We will write it as 1 minus 1. You can write it in any way. Then similarly find out for lambda equal to 12. For lambda equal to 12. This is B, this is C. Okay, for lambda equal to 12, what we are getting? x2. When we put lambda equal to 12, 1, 1, 1, 1. Just now I told you that in orthogonalization, we have to normalize the eigenvectors. Here also we normalize the eigenvectors by using L2 norm. Okay? E1 normalized form I am writing here is equal to 1 by root 2 minus 1 by root 2. E2 is 1 by root 2, 1 by root 2. Since norm of x1 is root 2, is norm of x2. I found norm for 1, 1, I am getting root 2. For 1 minus 1 also I am getting root 2. So I wrote there normalized eigenvectors. That is 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. Then with that I will get normalized matrix U. we wrote in the beginning, you can see u and v we will get with the eigenvectors. Okay, so u is formed with b and v is formed with c. So u is equal to, I will get first eigenvector, second eigenvector. In whatever order you are taking this, the same order you should follow to writing d also. D also, I used 10 and 11, sorry 10 and 12. When we write D also, first we should write 10, then we should write 12. The same order we should follow. Okay. So here 1 by root 2 minus 1 by root 2, 1 by root 2, 1 by root 2. This is your U. Similarly, we have to find out V. C matrix. For C, what are the eigenvalues? Minus lambda cube plus lambda square into trace minus lambda into sum of minors plus determinant of A is equal to 0. Same? How same? Only 2 you are getting, how can? You will get 3 eigenvalues, 12, 10, 0, yes, 10, 12, 0. Go to the beginning, starting where we wrote the description, go to the starting page where we wrote D is formed by square root of the eigenvalues, square root of non-zero eigenvalues. Just make a correction there. Square root of non-zero eigenvalues. Make a small correction. Non-zero eigenvalues. Okay? Now put lambda equal to 10 again and get the eigenvalues, eigenvectors. Tell me x1, x2 are x3, x4, x5. x3, x4, x5. What are the eigenvectors? All zeros? No. So maybe it's a case of repeated rows. See that once again? It happens only in that case. You might have taken 2 rows which are same. Then only you will get zeros. I said that x is a non-zero vector. X is a non-zero vector. You should select two different rows. If you are selecting 2 similar rows, then you will get all zeros. What is the third eigenvector? Minus 2, 1, 0. x3 is minus 2, 1, 0. What about x4? 1, 1 by 2, minus 5. Minus 5. You know that you have to take the norm, so it will become more difficult. So don't use fractions, make it as an integer. So 1, 1 by 2 minus 5 will become 2, 1 minus 10. But check whether it is right. Is this right? 1, 1 by 2 minus 5 is right. I told you the procedure to check. You can put whatever the answer you got in unused equation. Don't write that directly. Sometimes you will miss. You will not put minus y there. If you put only y, then you will get wrong answer. You have to check that in rough, whether your answers are right or not. Is this right? Minus 2, 1, 0. What about this? 1, 2. Third is right. What about this? 1, 2 minus 5 is correct. This is also right. Minus 2, 1, 0. Right? So, will normalize and will form V. Anything wrong? Which one? Are all right? Okay. Once we get the eigenvectors, then we have to write normalized eigenvectors and we have to find normalized modal matrix V. Okay. So which is given by V is equal to, normalize them. What is the norm of this? What is the norm of this? Root 5 will be the norm. Root 5 will be the norm, right? So we'll get this as minus 2 by root 5. Wait. There we used lambda equal to 10 first, right? Yes. There we use lambda equal to 10 first, and here also we use lambda equal to 10. There lambda equal to 12 next, and here also lambda equal to 12 next. Okay? Okay. So minus 2 by root 5, 1 by root 5, 0. Lambda 12 is? This is x5. Lambda equal to 12 is this. What about this? Lambda equal to 0. So I'll make this as x5 and this as x4 better. In whatever order you are writing, you should write again in the same order lambdas also. Okay? So then, what about the norm of this? What about the norm of this? 6, root 6. So 1 by root 6, 2 by root 6, 1 by root 6. And here the norm is 30. 5 square plus 2 square plus 1 square. So root 30. 1 by root 30, 2 by root 30, minus 5 by root 30. This is V. Then we need V transpose. Then we need V transpose because this is a real matrix. Can I write it like this? We can put these three and we can check its value is equal to A, or we can find out D from the value of A. So in two ways we can do that. What is this? 1 by root 6. What about this? 1 by root 30. Then 1 by root 5. 2 by root 6, 2 by root 30. Then 1 by root 6. What is U? What is U? 1 by 1 by root 2. Minus 1 by root 2, 1 by root 2. Put the matrix A. Put the matrix A here. What is A? 3, 1 minus 1. 3, 1, 1. This is 2 by 3, this is 2 by 2, this is 3 by 3. Right? So it will not work out now. Wait. What are the diagonal elements we got? What are the eigenvalues we got? 10 and 12, right? 10, 12. Now multiply them. See that what I did here? Yes, U D V star or V transpose. U is the eigenvectors what we got from matrix B, and V is the matrix which we got from the matrix C. I transposed this matrix and I got that as V transpose. So V transpose I have substituted here. Then D is the matrix which is formed by square root of the eigenvalues, square root of non-zero eigenvalues, and these square root of the eigenvalues are called singular values. Okay, square root 10, square root 12. You should not put 0 now, and it was 2 by 3 matrix, so I used 2 by 3 matrix only here. Yes, eigenvalues in B and C will be same. If one is more, then that will become 0. Okay, they will be same. Now check, multiply them, then that will give you the answer as A. Okay, So if you multiply them, you are going to get the same answer as A. So that process is called as singular value decomposition. So what we are doing, just I'll give a brief of that once again. Given matrix A, it may be rectangular, it may be complex, it may be real. So you can use singular value decomposition to find out the diagonal matrix. Okay? So what we are doing is, if it is a rectangular matrix, okay, we are writing B as A into A transpose, C as A transpose into A. Whatever may be the matrix, let it be square or rectangular, that is the process involved. You have to write A into A transpose as one matrix, A transpose into A as the second matrix. You have to find out the eigenvalues of B, you have to find out the eigenvalues of C and eigenvectors of B, eigenvectors of C, normalize them. One will become normalized modal matrix U and the other will become normalized modal matrix V. Okay? If it is a complex matrix, then UdV star, V star will become conjugate transpose. If it is a real matrix, then V star will become only V transpose. Okay? And the D matrix is given by square root of the non-zero eigenvalues. If you are getting any zero, you have to neglect it. You have to neglect it. Then that gives the singular value decomposition of the given matrix A. Decompose it into three matrices, where this is an orthogonal matrix, this is an orthogonal matrix. This is an orthogonal matrix, this is an orthogonal matrix. Okay? So this is singular value decomposition. And one thing I want to tell you from orthogonalization, after that we'll stop. In orthogonalization, do you remember that we need to write it as sum of the squares form? Sum of the squares form. Sum of squares form or canonical form. Lambda 1 y1 square, lambda 2 y2 square, lambda 3 y3 square. Recall. We used to write after orthogonalization, after diagonalization, we used to write lambda 1 y1 square, lambda 2 y2 square, lambda 3 y3 square as canonical form or sum of the squares form. In orthogonalization, we'll find eigenvalues, we'll find eigenvectors, normalize them, then the resulting modal matrix will be an orthogonal matrix, then P inverse AP equal to D will become P transpose AP equal to D. Why? Because P is an orthogonal matrix. P inverse will be same as P transpose. So P inverse AP equal to D will become P transpose AP equal to D. Okay? It's an orthogonal matrix. So after that, the canonical form is given by Y transpose dy. Y transpose dy. Okay, Y transpose dy. D is the diagonal matrix. Y, you will write it like this: y1, y2, y3. Diagonal matrix into y1, y2, y3. When you square it, you are going to get this, or when you multiply these three, you are going to get the form as canonical form. That is lambda 1 y1 square plus lambda 2 y2 square plus lambda 3 y3 square, where lambda 1, lambda 2, lambda 3 are the eigenvalues. Okay? From that you may be asked to write the rank, index, signature, nature. Rank, how many eigenvalues are non-zero, or how many terms are there in the canonical form. If you have 0, then only 2 terms. So rank will be 2. Index, how many number of positive terms are there, then that will be taken as index. Number of positive eigenvalues, that will give you index. Signature, how many positive minus how many negative, that will give you signature. Nature, if all the eigenvalues are positive, positive definite. If all the eigenvalues are negative, negative definite. If one value of, or at least one is 0 and the remaining are all positive, then we say that as positive semi-definite. If at least one is 0 and the remaining are all negative, then we call it as negative semi-definite. If contains both positive as well as negative, then indefinite. Indefinite. Okay? Let's just write that LU decomposition. we'll write the coefficient matrix as the product of upper triangular and lower triangular matrices. LU decomposition, splitting the given matrix into two parts, lower triangular matrix, upper triangular matrix. But if you observe here, yes, if you observe here, I wrote here A, B, C, D, E, F, some constant. This is lower triangular, this is upper triangular. If you observe here, I did not write some constants. See, did I write all the constants here? No. Either here I should write 1, 1, 1 or here I should write 1, 1, 1. Otherwise I won't get the answer. Okay, don't write all the constants. In one of the two matrices, you should have 1, 1, 1 along the main diagonal. Will be in terms of the other. A will be in terms of B, B will be in terms of C, and so on. So to get the answer, you have to take along the main diagonal of L or U as 1, 1, 1. Then you can solve it and you can get the answer. We'll write the matrix A here. We'll put the matrix L here. We'll put the matrix U here. We'll multiply these two matrices. We'll compare with this. We'll get all the constants. We'll form what is L, what is U. Okay, just I am giving the rough picture of what is there in LU decomposition. Okay, A equal to LU. L and U you have to multiply, you have to equate each term with A, then you are going to get all those constants that will give you the lower triangular matrix and the upper triangular matrix. AX equal to B will become LUX equal to B. Then you will suppose, okay, UX as Y, UX as Y, then this will become LY equal to B. Procedure I am telling you. You know L, you know the matrix B, then you can find out the unknown Y. Put this Y here, then the unknown is X, you can find out X. Okay, write the process. Okay, after writing that right there, since L is known, B is known, Ly equal to B, after that write there, since L is known, B is known, we get the value of Y. Use this Y in Ux equal to Y. In Ux equal to Y. Since U is known, Y is known, we can get the value of X, which is nothing but a solution. Okay. So in the afternoon session, you will have for 1 hour ML, then after that I will start statistics part.